Hi everybody! In this video we are going to look at dividing expressions that have exponents in them. So in the first problem we have x to the 5th power divided by x to the 4th power. So what I'm going to do is I'm going to write out x to the 5th power as x times x times x times x times x, and I'm going to write out x to the 4th power as x times x times x times x. Okay, now each x divided by x cancels, right? X divided by x is just equal to 1. Anything divided by itself just equals 1. So x divided by x, that equals 1. Another x divided by x, that equals 1. Another x divided by x, that equals 1. And another x divided by x, that also equals 1. So what we are left with is just x by itself in the numerator. If we wanted to, we could write that as x to the 1st power, just to kind of try to figure out the rule as we go. So in the next one, we have y to the 7th. So we have y times y times y, 4, 5, 6, 7. And then we have divided by y times y times y. And again, a y divided by a y, I'm just going to pick them in the middle here. It doesn't really matter where you take them from. 1y divided by 1y cancels out because that's just y. Now we're left with y times y times y times y in the numerator. So that is y to the 4th power. So see if you can think about what the rule might be when you have expressions with exponents and you are dividing, what the rule might be. What does this end up being here, this exponent? All right, let's look at the next one. 3 to the 8th power is 3 times 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 3 divided by 3 squared, or 3 to the 2nd power, which is 3 times 3. So if we take a 3 from the numerator and a 3 from the denominator, they cancel. And another 3 from the numerator and another 3 from the denominator, they cancel. And we are left with 3 times 3 times 3 times 3 times 3 times 3. We are left with 3 to the 6th power in the numerator. And notice these exponents were 8 and 2. So in case you haven't already guessed it, the rule says that if you have two expressions with the same base, you are going to subtract the exponents. Okay? Now, we didn't see an example where the exponent in the denominator was bigger than the exponent in the numerator, so I'm going to add one over here. What happens if we had a to the 3rd power over a to the 5th power? What do you think would happen here? If we write this out, this is a times a times a, and in the denominator it's a times a times a times a times a, and then when we go to cancel, we've got a and a there in the numerator and denominator, and another a in the numerator and denominator. So we are left with a times a, but in the denominator. Okay, and we can't leave nothing in the numerator, so we just put that denominator under 1. All right, so when we have coefficients or numbers in front of our expression, we are actually going to divide those. So I'm going to write this separately. I'm going to write this as 5 over 10 and y to the 5th over y to the 2nd, right? Because remember, when we learned about fractions, we learned to multiply fractions, we multiply straight across the top and straight across the bottom. So if I were to multiply those two fractions, I would end up with 5y to the 5th over 10y squared, which is what I started with. I know that 5 divided by 10, I'm going to look at this fraction, is 1/2. Okay, now I'm going to look at y to the 5th divided by y to the 2nd, and I'm going to use that exponent rule up here that I just learned I'm going to subtract the 5 and the 2. So this is y to the third power. So the answer is 1/2 y to the third power. That also could be rewritten as y to the third power over 2, or 1y to the third power over 2. Okay, but those are equivalent expressions, so it doesn't matter how you write it. Right, in the next example, I'm going to look at 6 divided by 3, and then I'm going to look at m to the 8th over m to the 3rd separately. So I know that 6 divided by 3, that is 2, and m to the 8th minus m to the 3rd, using the rule that we learned about dividing expressions with exponents, that is m to the 5th power, because 8 minus 3 is 5. Now the last example we're going to look at has a's and n's in it. So what I'm going to do is I'm going to look at those separately. I'm going to rewrite this as 8 divided by 4, and a to the 7th divided by a to the 3rd, and n to the 3rd divided by n to the 5th. All right? So we have 8 divided by 4 is 2, right? Then we have a to the 7th divided by a to the 3rd, so the rule tells me to subtract those exponents. So 7 minus 3 is 4. And then this last one, n to the 3rd over n to the 5th, there's more n's in the denominator, so I know my answer is going to end up being in the denominator of this fraction, okay? And so that ends up being n squared, because you basically can subtract this 5 and this 3, because there's n times n times n times n times n in the denominator, and then n times n in the numerator. So just like we saw up here with this example, we subtracted essentially the 5 and the 3, and that ended up with a squared in the denominator. The same thing is happening here. The n squared is in the denominator. Okay, so what I want you to do now is the practice problems on the next page in your packet, and then you can check the answers with the link in Canvas. Hope you're having a good day, and I will see you on Wednesday.